Okay, we are picking up where we left off yesterday in lesson 1.6. I had already done across the x-axis, right? And so you have that in your notes. We talked about, and I guess I can write it real quick again here, but we talked about across the x-axis was the idea it was negative f of x, right?
Yeah.
And that's what you have up top in your notes. And we have that up top in the notes. For this one, it's the negative times the fraction. And we talked about options yesterday, right? We talked about the fact that if that negative is directly in front of the fraction bar, that could happen. Or you can multiply the negative into the numerator or into the denominator. But you don't get both. Because if you multiply negative on top and bottom, it's no longer a negative, it's multiplying by a positive. And so, I believe what I wrote before we left is I multiplied the negative into the top. It said negative 5x plus 9 over x squared plus 3. Sounds familiar, right? And we are getting ready to start then going across the y-axis. What's the rule for going across the y-axis? Yeah, it's f of negative x, right? So we've talked about that. What does f of negative x mean?
It shrinks by a factor of c. C is less than.
You're thinking vertical shrink and stretch. We're talking reflections here. How do I do the math here for f of negative x? Every place I see n x, what am I going to replace it with? Negative x. Okay, since it's f of negative x, every place I see x, I'm going to replace it with negative x. So it was 5 times x. I'm going to write it as 5 times negative x. Still minus 9. It was x raised to the power of 2. Now I'm going to say negative x raised to the power of 2 plus 3. And of course, you should simplify, right? We shouldn't leave it in this awkward form. This is just me kind of showing, trying to get you to process how this works. So what is 5 times negative x? That now becomes negative 5x, still minus 9. What's negative x raised to the second? X squared. And then it's still going to be a plus 3. Okay? So, the difference here is, basically if you're putting the negative x into an x term, it changes the sign of that term. Now, if you put the negative into a situation you square it, it doesn't change anything, does it? Are we good on that one?
Will it always be like that?
Like what?
Where we just flip it?
Yeah, if you're putting a negative x into a term, it's just going to change the sign on the term. So if it was 5x, it now just becomes negative 5x. The difference here is that the minus 9 stays because there was no x. The plus 3 stays because there's no x. This one, it was a negative x, but then you're squaring it, so it stays.
I see why I said the stretches and shrinks because I'm just reading across it. I'm going to put a line.
Okay, our other reflection that we have to practice with is the one that is, I don't know if I should be saying across the origin or through the origin, but something about the origin, right? And according to our reflection rules, what does it say about if we're reflecting through the origin? Negative f of negative x. So this time we're doing both of the techniques we just used. We're going to multiply the whole item by a negative, and we're going to put negative into each of the x values. So I'm going to kind of combine them, and then we'll take it step by step. So I'm going to say a negative times the whole fraction. And then I'm also going to say, okay, it's 5 times negative x minus 9 over negative x raised to the second plus 3. So I've just used both of the same tricks we've used. I've had the negative out front, ready to multiply in, and I have the negative x that we are plugging in here. My recommendation is maybe we work with the x inside here. So, and then I'll multiply that negative in at the moment. Just like last time, 5 times negative x is going to be negative 5x, still minus 9, over, what was negative x raised to the second? Positive x to the second plus 3. And now, if I multiply that negative in, what did we do over there on the first one? We specifically multiplied the negative just to the numerator, right? And so that's what I would do again, is I would take that negative and multiply it to both terms. And if that's done, this becomes positive 5x plus 9 over x squared plus 3. And that is your negative f of negative x. And if we really wanted to, we could have taken our answer from part A or our answer from part B and just, adjusted that. But
Well, I also do it to the numerator because if it's double negative, it just ends up
right. And you could, generally we pick the numerator, but you could use the denominator as an option as well. Okay. Ready for the next page? Okay. So.
It worked.
That's exactly what I was thinking. It worked. Learning curve still. Okay. So example 4. Finding stretches or shrinks. And you'll notice in the directions it says state the horizontal stretch or shrink. And we're actually going to talk about horizontal and vertical here. Okay, so we are going to talk about horizontal and vertical stretch and shrink. Now, you're probably going to want to be flipping back and forth to the page up front, right? And what we talked about yesterday, we had that vertical where the number was multiplied out front. And then we had a horizontal where the x value was divided by a number. So, as we look at A, we're all basing this on the parent function x squared. So your parent function is y equals x squared. What's being done to x squared? That's what we, are we stretching it? Are we shrinking it? Is it horizontal stretch or shrink? Is it vertical stretch or shrink? What are we doing? Now, as we look at A, y equals 2x squared. Thoughts on this one? Go ahead.
Maybe because it's more than 1, it would be stretching.
Okay, the number is more than 1, and so it's a stretch. However, we have to be specific today. Is this a vertical stretch or a horizontal stretch?
Good question.
Vertical.
Vertical? Why?
Good
Huh?
guess. It's a guess.
It's a guess, okay. I agree with vertical. Why do I agree with vertical?
Because if it's in front of the x, like if you're
Okay.
multiplying it.
Yeah. This is a number being multiplied by the quantity x squared. It's not in with the x. It's a number, a constant being multiplied by the quantity x squared. So this goes back to your traditional, what we've done in Algebra 2. This is a vertical stretch by a factor of 2. Nothing fancy here. So I'm just going to write that one down. Vertical stretch by a factor of 2. Are we okay with that one? Okay. B. Y equals 4/10 x raised to the power of 2. Thoughts about this one?
Horizontal stretch by, or horizontal shrink by 0.4.
Partially right. Okay, his response was horizontal shrink by 0.4. If you go back, I agree we want to talk horizontal in this problem. There's just a slight catch with the way it's set up. Okay, and what makes us think we want to talk horizontal here?
The exponent's outside of the parentheses.
Yeah, the exponent's outside the parentheses. So it's 0.4x, and that's raised to the power of 2. So that means that 0.4 is in there and being raised to the power of 2 as well. So, we do want to think horizontal. Now, the key is I disagree with the factor. Okay? He said 0.4, which that's the number there. It makes sense to say it. But if you flip back to that previous page, with a horizontal stretch or shrink, the form was x divided by c. Is this x divided by 0.4? No, this is x times 0.4. Okay, so there's a trick here, which I have to walk you through. So in order to be able to talk about the horizontal here, we're going to kind of change this so that it is x divided by something. So, okay, work with me here. What do you know about 0.4? Read properly, that is what? I mean, I say 0.4, I'm as guilty as you guys, but 0.4 is what? 4 tenths. And 4 tenths reduces to 2 fifths. So with that in mind, do you agree we could rewrite this as y equals 2 fifths x quantity squared?
Yes.
I haven't changed anything, have I? Well, I mean, I've changed the decimal to a fraction form, but it's still equivalent. And the reason I did that, okay, multiplying by a fraction is the same as dividing by the, how do we divide fractions?
Multiplied by the reciprocal.
Multiply by the reciprocal, yes. So if this is multiplying by the reciprocal, to back it up to division, we can, where do I want to write this? We can rewrite this instead of 2 fifths times x, x divided by 5 halves, quantity squared.
So you have to change to 5 before you.
Well, in order to give an appropriate horizontal shrink or stretch answer, because I said earlier, I liked horizontal. I do want to talk about horizontal here, but I had to disagree with the 4 tenths. And then I had to disagree with 4 tenths because it was 4 tenths times x. And we need it to be x divided by something. So, x divided by 5 halves would be the same thing as saying x times 2 fifths. Because in order to divide this, you would multiply by the reciprocal. I just kind of worked backwards. So now, if we want to say horizontal, which I do want to say horizontal stretch or shrink by what factor? Okay. Well, just the number value, the c value is just 5 halves. Is this a horizontal stretch or shrink now? What do you know about 5 halves? It's bigger than 1, isn't it? It's a fraction, which is misleading. It's bigger than 1. So this actually becomes, and I'm going to leave a little room at the bottom here if you can, because I want to talk about something else here real quick. But officially, this is actually a horizontal stretch. Officially, I should say by factor of 5 halves, but my space is limited. So this is a horizontal stretch by a factor of 5 halves. Now, Does anyone see a different way we could have gone with this problem? That would lead us more towards a vertical answer? Take that original equation and rewrite it. What is 0.4x raised to the power of 2? As in, what is 0.4 times 0.4?
0.16.
0.16 x squared. If it was written in this form, I'm trying to show the difference here. If it's written in this form, y equals 0.16 x squared, what can we say now instead about this stretch and shrink?
It's less than 1.
It's less than 1, it's a shrink. What kind of shrink is it?
Vertical.
It's a vertical shrink. Because the number is multiplied out front. So, we just showed how this is also a vertical shrink by a factor of 0.16.
Is there a word for that? Kind of like how we add 1 to 1? Or is it just a horizontal and vertical?
No. And here's the deal. I talked yesterday. Every horizontal and vertical, I mean, think about this. If it's a horizontal stretch, what's that doing? Horizontal stretch is making it wider. What's a vertical shrink doing? It's pushing it down. And as it goes down, what do we talk about? It goes wider. So it makes sense that a horizontal stretch would also be equivalent to a vertical shrink. Okay? I mean, if we really wanted to, we could back up to A and take this vertical stretch and we could rework it. It'd take more work there. Okay? But we could rework it and come up with an equivalent type answer there. Now, which one were you really expected to do here? The horizontal. Okay? But I'm trying to show you the connection, and technically both are equivalent. But we're more looking for the horizontal here because it is in parentheses with the x. Questions there? Have I made the connections? I'm not sure Craig's happy with it, but.
No, I get it. I'm more trying to understand the first part.
How we came up with the 5 halves?
Yeah. Well, I understand you come up with the 5 halves. I don't know. I'll probably figure it out as we go on.
Okay, well, let's try. My thought is, let's try C.
Yeah.
Long
Yeah,
shot.
like that.
Yeah, okay, because as you guys look at C, what do you notice about C? It's the same type thing as what we just did on B, isn't it? Because this 5 is in parentheses with the x, right? Now, what is 5 as a fraction we know is 5 over 1, right? So multiplying by 5 over 1 is the same as dividing by what?
Over 5.
1 over 5, right? 1/5. Okay, the whole reciprocal here. So when we think about this, we can think about this as, instead of 5 times x, x divided by 1/5 quantity squared. Because it was 5 times x, and so multiplying by 5 is the same as dividing by that reciprocal.
So anytime that you see that in parentheses, you're going to be using those.
Yeah, you're going to be thinking horizontal and using reciprocal because it's there with the x, it hasn't been squared yet. Okay, so what is this one? If it's x divided by 1/5 quantity squared,
Would it be a horizontal shrink by a factor of 1? Yeah, 1.
Yep.
Or could it be a vertical stretch by a factor of?
check your math, but yes.
I'm in 25.
You had the right idea, but yes. Okay, so what I'm going with right now is that this is a horizontal, he said shrink, because 1/5 is less than 1, right? So horizontal shrink by a factor of 1/5. That's your horizontal answer. However, also noticing 5x quantity squared could be rewritten as 25x squared, not 10x squared, right? 25x squared. And if you look in this form, now it is, because it's a number multiplied out front, it's a vertical. This time it's a stretch. And it's by a factor of 25. Okay. Does that help clear up some of the confusion there? I mean, it's a little different. I get it. What about D?
Vertical strength by 1/3.
Vertical shrink by a factor of 1/3 because it's just 1/3. It's times the x squared. The 1/3 is not in the parentheses. So, okay. So vertical. Bless you. Shrink by a factor of 1/3. Are we tracking sneezes here?
Let's keep it sneezing. I don't know, it's like you sneeze correct.
I do remember a sneeze in here yesterday, so. Okay. Got the idea here? Okay, let's try example 5. Get moving here so we make sure we don't run out of time. Still talking about stretches and shrinks, which I think stretches and shrinks, if I had to guess, to me they're probably one of the more difficult, things to think about in this lesson. The translations, those are a piece of cake. Reflections, but, the stretches and shrinks take a little work. Start thinking about A. Hello? I do. Can I can't tell him that, but okay, I'll tell him what it's not. Okay. Okay. Bye. Connor. Barb needs you, but it's not a quarantine. You might be able to guess what else it is, but.
Is drugs in his car?
Obviously. Oh wait, is it drug? Do we have that? Was it that time? I love those things.
When she's like, normally she doesn't tell me what she needs. So that's why I was like, okay, I have to tell him or he's going to freak out on me.
Oh,
And it's not a quarantine. And you're going to freak out. And yeah, no.
Thanks, Craig.
Yeah, I sit next to Madison Decker. She just got tested. I guess we followed it. So I might get.
See, but they should have done that yesterday. I'm guessing because if Friday was the last time she was in school, depending on when she's showing symptoms, we might not have to contact trace that one. Does that make sense?
Yeah.
Because it's 48 hours before you start showing symptoms. So they might be able to say they don't have to contact trace that one because it was Monday.
Do you know anything about
So.
Jaden Archer? Because I know he got one.
Okay, I know I gotta keep going here.
Sorry, just real quick. Would I be good? Because like the last time I was anywhere near her, which I wasn't really near her, was Thursday. So.
I would definitely think you'd be. Well, again, it depends on when she started showing symptoms.
All right.
I mean, I'm going with if they haven't already quarantined people, if they didn't quarantine people at the end of the school day yesterday, they've decided that they don't need to quarantine. So, but was she at school on Friday?
I don't know.
Yeah, so.
I don't remember.
No, I'm not near her.
Yeah,
in
she was.
school.
I don't know. I'm going with if they haven't quarantined yet, they should have done it at the end of the school day yesterday.
That's
So.
what I'm hoping.
Okay, moving along here. Okay, we have an f of x function, right? X cubed minus 16x. That's what we're using. Find the equations for the following non-rigid transformations of f of x. That's just official lingo there. Okay, don't let that flip you out. So on A, we're asked to do a vertical stretch by a factor of 3. Okay, so what indicates a vertical stretch by a factor of 3? How do you do a vertical stretch?
Has to be
Okay,
as much.
and I'm going to just write out the original function as f of x equals x cubed minus 16x, right? Oh, I didn't leave myself much room there.
So just put 3x here.
F of x equals, I was trying to leave a gap and I forgot, x cubed minus 16x. If you flip back to the previous page, right, in order to do a vertical stretch by a factor of 3, it says we need to do 3 times f of x, right? Because vertical, you just multiply by the function. So what's that mean I have to do here? If it's 3 times f of x, that means I have to take this, I have to take 3 and multiply it into the function. Okay? Vertical is a piece of cake. That's the easier one, right? So we're just taking 3 and multiply it into the function. And so if we rewrite this, what happens when you distribute that 3? Three x cubed minus 48x. I've got my mental math right there. Okay, so vertical, it's 3 times f of x, just multiply everything by 3. Okay. B. B says a horizontal shrink by a factor of 1/2. How do we do a horizontal shrink according to the previous page?
F times x over c.
Okay, f of x over c. What is c? C in this case is going to be 1/2. So because it says horizontal, we're taking the x value and dividing it by 1/2. Now, side note, let me ask you a question, because I don't know about you guys, but I really don't want to do x divided by 1/2 every place I see an x. So, what do you guys know about x divided by 1/2? It's the same as x times 2, because in order to divide fractions, we keep, change, flip. And so dividing by 1/2 is the same as multiplying by 2 over 1. So I don't know about you guys, but instead of saying f equals x over 1/2, I would rather say f of 2x. So instead of every place I see an x, I'm going to replace it with x divided by 1/2. I would, every place I see an x, I'm going to replace it with 2x. Does that make a little bit of sense? So go back to your original function. It was x raised to the power of 3. Instead of x raised to the power of 3, we're going to say 2x raised to the power of 3. Notice I put that 2x in parentheses. Instead of minus 16 times x, it's going to be minus 16 times 2x. Every place I saw an x, I replaced it with 2x. And then from here, it's just doing the cleanup. What is 2x raised to the power of 3?
Cubed.
8x cubed minus 16 times 2x minus 32x. Is Jacob impressed with that one?
I like that.
You like that one? And as I said, if you'd rather start by putting in x over 1/2 in each of these places, and then raising it to the third and all of that, you can do that. To me, I know you guys are going to, 2x, I might be able to convince you to do. X over 1/2, you guys are going to fight me on. So. Okay. We good? So I'm going to say, let's look at example 6. Now, I think, okay, so, was it your class yesterday? Yeah. I am then going to have to erase all that, aren't I? But I did. I talked to Mrs. Okay, so we'll try the circle. Okay, I got it to work. Oof. Okay, example 6. Eventually, this will just be easy for me. Right now, I have to really think.
Is that what you have to do every time?
I think it is going to have to be. I mean, the other way I was doing it, I had to turn the whiteboard on and off. Not like I had to keep holding on my 2 fingers to get the whiteboard, accessories to come back up and stuff. I didn't like that either. So.
I feel like Miss Rogers just had her eraser set
It was really, really big, so she just went.
I don't know. Maybe I can do that. I'll have to try that next. Okay. Example 6. Combine transformations in order. The graph of y equals x squared. So notice what we're starting with. You always have to be told what you're starting with. Undergoes the following transformations in order. Find the equation of the graph that results. So here's what I'm going to do. We have y equals x squared, right? We're just going to write the equation step by step. So each time I'm going to add a step. So how do I show a horizontal shift 2 units to the right? It'd be -2. What'd you say? In parentheses. So if I say y equals, not quite. It's not x squared minus 2 in parentheses. X minus 2 quantity squared.
Yeah.
Because if you just say x squared minus 2 and then just put parentheses around it, that's still vertical. So x minus 2 quantity squared. That's taking us right to. Now what are we going to do? Now it says vertical stretch by a factor of 3. How do I show a vertical stretch by a factor of 3? Okay.
No.
Right? We're going to put it before the x, not in parentheses, and we are multiplying. So 3 times x minus 2 quantity squared. Okay. What I'm doing is I'm just adding on each transformation step by step. Could you just put this all together in one right from the get-go? You could. But as a teaching technique, I need to take it step by step. Okay. Last step. Vertical translation, 5 units up. So it's still 3 times x minus 2 quantity squared and then plus 5. And my equation kind of goes downhill there, but it's there. Okay. So notice we just added them step by step in the order they showed us. Now, what's part B say? Yeah, in the opposite order. So, okay, so right, we're going to start with 5 up, which means we're going to say y equals what? X squared plus 5. Then what? Vertical stretch by a factor of 5. What do I have to multiply 3 by? Everything that's already there. So if I'm trying to stretch this, I'm going to say 3 times x squared plus 5. And then, what am I doing?
Shifting it 2 units.
Okay, shifting it 2 units to the right. Well, just like earlier, how do we do a shift 2 units to the right? We put it directly on the x. Okay, so it's still going to be 3 out front times, but now instead of x squared, I'm going to say x minus 2 quantity squared plus 5. And you'll notice I used brackets instead of parentheses, just so I didn't have double parentheses. If you wanted double parentheses, you could use double parentheses too. But the key is, because we had these, we went up 5, then we had the stretch of 3, and then the shift of 2, this 3 has to be multiplied by everything. That's the big difference from last time. Last time, we stretched by 3 and then added 5. This time, we added 5 and then stretched by 3. So that has to be done on everything. Okay? And then that horizontal left or right is going to be right there on the x every time, no matter what. Okay? You don't like that? It's, I mean, order is a tricky thing on translations. It really is. So, okay, I just looked at the time. I've got 4 minutes to talk about this bottom part. Okay, the graph of y equals f of x is shown. It's this weird little graph right here. Determine the graph of the function y equals 2 f of x plus 1 minus 3 by showing the effect of a sequence of transformations on the graph of y equals f of x. So, first of all, realize this graph right here is f of x. It, doesn't have an equation or anything. That's just the graph right there. Now, dissect the pieces. We've got a 2, a plus 1, and a minus 3. What do those pieces mean? The 2 is going to be a what?
Stretch.
It's going to be a stretch, specifically a vertical stretch. What about the plus 1 and the minus 3? Hello? Yes. I will do that. Bye. Jacob Sorlier needed in guidance at the end of the hour, which is very soon. So, what about the plus 1? It's going to be left 1. And what about the minus 3? That's going to be down 3. I don't think you guys have an issue figuring that out, do you? Okay, so here's what it comes down to is now we have to look at, okay, what's being done to the x first? Even before it's stretched, I would have said it's moved left 1. Now, and here, in all honesty, the left 1 and the stretch could be done either order. What's going to have to be done at the end is the minus 3. So, with that in mind, if we do the left 1 here, and this is where I'm afraid I'm going to run out of time. Okay, so first of all, note over here, we have a dot at negative 2, yes? Negative 2, 0, a dot at 0, 2, and a dot at 4, 0. With that in mind, if I go left 1, okay, instead of being at negative 2, 0, I'm at negative 3, 0. Instead of being at 0, 2, I'm at negative 1, 2. Instead of being at 4, 0, I'm at 3, 0, right? Does that make sense what I did there? And officially, I see that as like a curve and then a straight line. Look at my points. Here's the one that we really have to work with. How do we do a vertical stretch? And since it is a vertical stretch, y values, the vertical values, multiply by 2. So that means these numbers that are already on the x-axis, guess what? They stay. This number over here that is 2 up, if you stretch that by a factor of 2, 2 times 2 means this is now going to be 4 up. Okay? And then the final piece would be taking it down 3. Okay? I'm going to go ahead and finish this. You guys are welcome to go. Make sure you get the homework done, okay? Make sure you get the homework written down. So down 3. Whoops. That didn't work. No, I don't want. Okay, I have an issue here. Here. I'm going to have to make this 3 smaller here.
Keyword baby.
Okay, so down 3.
Yeah,
If it was left 3, we're going to go left 3, down 3. Okay, I am too close to the bottom of the board. Can you tell? Sorry, anyone watching this video. So sorry, Ethan. Left 3, down 3. Over here, it was right 3. That's going to be down 3. The one that was left 1, up 4 is now going to be left 1, up 1. I think if you do the math. This doesn't look exactly right because I had issues with the tools down there. Your homework, if you didn't already get it, is on page 136.
She's like the best.
And it is 2 through 32 evens. Let me know if you have any questions.